All right, we are being recorded. A few things to get through before we get into our main lesson this week. First thing is, it's not too important. First thing is, I'm going to apologize before. There will be no help session this week, which doesn't affect too many of you. I mean, there's only one or two students that ever show up for, well, there used to be more, but I mean, the material has gotten a little bit easier, so it's only been like one or two in the last couple of weeks. But there will be no e-session, or I'm sorry, no help session on Wednesday. I apologize. I am tied up with other things this week, so I cannot be there. But as I said, there's only been one or two that have been coming lately. And then the second thing is, this week we do not have school on Friday, and we don't have school on Monday. So how do we do a main lesson then? Well, the main lesson is going to be next week on Tuesday from 10 to 11 o'clock, okay? So next week on Tuesday from 10 to 11 will be our main lesson. Now, I know not everybody will be able to attend because you have other classes at that time, okay? So don't change your schedule, just watch the recorded session, okay? Cannot, sorry about that. So next week, our main lesson will be Tuesday, 10 to 11. The reason we don't have school on Monday. Yay, I'd rather not have school on Monday and do it on Tuesday. All right, so this week we're going to be talking about sequences and series. A sequence is just a list of numbers in a specific order, and each one of them has a term. For example, the first one would be the first term. This is term number 1, term number 2, term number 3, term 4, term 5, term 6. So when we talk about a sequence, if I ask you what is the fourth term of the sequence, usually we would just do N4. That means the fourth term. And you would just say, oh, it's 7. Okay, so terms and sequences. And then we're going to also talk about series this week also. Now, there are two different types of formulas that we're going to be learning this week. The first one is called an explicit formula, and that one's the easy one. An explicit formula just gives you the term of any, the value of any term you want. So for example, if they write down a sub n is equal to 2n plus 4, and I asked you for, let's say, the first term, what would the first term be of this sequence? And all you'd have to do is plug 1 in. You just plug, nope, not 4, but 6, because if we put 1 in here. So really, if they write it this way, a sub 1, that means what is the first term of the sequence? So you'd plug 1 in for n. So 2 times 1 is 2 plus 4, that's 6. So what is a sub 2? That means what is the second term? That would be 8, yes. What if I asked you, what is a sub 100? Could you figure it out fairly easily? No, 204. I sure hope you can figure it out easily. You just plug in 100 for n. This is called an explicit formula. It is the easy ones. Now, when we get to a recursive one, some of you are going to not understand what I'm talking about. Okay, but an explicit formula is fairly easy to do. Okay, an explicit formula, you can. Now, next week we're going to be talking about arithmetic sequences, and we're going to be writing explicit formulas. But this week, no writing. This week, they're going to give you the explicit formula, and you're going to be able to tell me what the terms are. So, for example, if I give you a kind of a harder one, let's say I gave you a sub n is equal to 2 a sub n plus 5 over 3. And I asked you to give me the first 3 terms. Okay, what would they be? Oh, that's coming. That's coming, Joseph. So what would the first 3 terms be here? If I asked you, if I gave you this explicit formula and I said, what are the first 3 terms? What would you say? 7 thirds, 9 thirds, 11 thirds. Okay, so if I put 1 in here, that would give me 2 times 1, which is 2 plus 5, that's 7 thirds. Agreed. Then if I put 2 in here, 2 times 2 is 4 plus 5, that's 9 thirds. And what was it? If I put 3 in here, 6 plus 5 is 11 thirds. Okay, got it. So fairly easy, right? Just giving, terms. All right, that's an explicit formula. Now, so this one, oh, this is number 1 on the assessment, I believe. Okay. Yeah, improper works. I would just leave them as improper fractions. Yeah. You're just plugging in numbers. Yep. So in this problem here, this is problem number 1. It says write down the first 4 terms in the sequence. Don't simplify. Don't put them as fraction or decimals. Just leave them as is. So what is the first term? So if I put 1 in there, and usually you could write it out, ace of 1 equals, and then you'd put 1 in here. So that's 3 over 1, which is 3. So you can put 3 or 3 over 1. What is the ace of 2? It's not 5. 5/8. It's 5/8. Why is it 5/8? Well, I put 2 in wherever I see n. So this would be 2 times 2 plus 1 over, well, that's n to the third, so that's 2 to the third. 2 times 2 is 4 plus 1, that's 5. 2 to the third, that's 8. That's 5/8. What about the third term? What is the third term now? So you plug 3 in. 7 over 27, let's check it out. So I put 3 in here. So that would be 2 times 3 plus 1 over 3 to the third. Well, 2 times 3 is 6 plus 1, that's 7. 3 to the third is 27. Yeah, that's it. So some of your answers are going to be crazy numbers. No big deal. No big deal. Just leave them. Don't change the fractions. Just leave it as is. That's what I'm looking for. Yeah, you could go to 1/3, but just leave it as 7 over 27. So that would be okay. I wouldn't mark that wrong. Oh, no, it's not. Yeah, 7, that's not right. 1/3 is not right. That's not right. All right, so this is an explicit formula. Now, a recursive formula is much harder. A recursive formula, and I don't like this where they give you this. A recursive formula, they always give you the first term. Ace of 1 is equal, let's say 2 here. So a recursive formula uses the previous number to get to the next number. What do I mean by that? So what they're going to do in a recursive formula, they're going to tell you what the first term is. Okay, it's 2. Then to get to the next term in your sequence, they're going to tell you what to do. 6 times ace of n minus 1. Ace of n minus 1 really means the previous term. So if you're looking for ace of 2, you're going to have to use ace of 1 to get to ace of 2. You're going to have to multiply 6 times ace of 1 to get ace of 2. So this would be 6 times, and then if you put 2 in here, 2 minus 1, that really means ace of 1. 6 times ace of 1. Well, we know ace of 1 is 2, right? So this would be 12. Now, what would the next term be? Okay, and if you think about these, you're always taking the previous term to get to the next term. So what would my next term be in this problem? I go 2, 12. What is the next term? And this is called a recursive formula. 72. That is correct. Because I'm going to take, so if I want ace of 3, I'm going to go 6 times ace of, well, 3 minus 1, that's 2. So 6 times ace of 2, we said was 12, so that's 72. If I wanted to find ace of 4, guess what? I would do 6 times ace of 4 minus 1. Well, that's 6 times ace of 3. That's a recursive formula. You're using the term previous to it to get to the next term. If I asked you to find ace of 100, you would be pulling out your hair, because In a an explicit formula, it's super easy. You just plug 100 in for n, you get your 100th term. But to get ace of 100, you'd have to find ace of 4, you'd have to find ace of 5, ace of 6, ace of 7, ace of 8. You'd have to find every single term up to 100. Would I ever do that to you guys? No. Yeah, and the only way to get ace of 99 is to get ace of 98. To get that, you have to have ace of 97. You have to get all of the previous terms. That's why recursive formulas aren't used that often, but you will see them once in a while. How do I know when something's a recursive formula? Right off the bat, they always give you the first term. That's the clue that you're using a recursive formula, is when they give you the first term. So for example, in this problem, it says find the first 4 terms in the sequence. Ace of 1 is 29. They gave us the first term. That's where, okay, so hopefully you don't get the first term wrong because it's given to you. All right, what's my next term? What is ace of 2? 39, exactly, because I'm just taking ace of n minus 1, so if I wanted ace of 2, it really is ace of 1 plus 10. So that's 39. And then my next term would be 49. And my next term would be 59, because look at what I'm doing. To get to the next term, I'm just adding 10. 69, 79. So this one's fairly easy to do. But this is called the recursive formula. You could say just, well, if I asked you for the first 6 terms, you can't just say add 10. You have to give me the terms that, it is. But this is, mathematically speaking, this is how they write it. Okay, now, this is where, I love these types of problems. This is because a series is when you add all the terms together. So if you had a sequence, so if I had this sequence right here, if I had, let's say I had a really simple sequence, and my sequence was 1, 3, 5, 7. That was my whole sequence, okay? And then I asked you, what is the sequence or the series of this? When they talk about series, they mean you just add up all the terms. Oh, well, if I had to add up all these terms, 1 plus 3 is 4, plus 5 is 9, plus 7 is 16. That would be 16. So, but this symbol right here means the sum. So anytime you see this symbol here, it means sum. And it usually looks like this. It usually will start like this. N equals 1 to 5. So what this is saying is you start at 1, you stop at 5. Let me see if I have a clean sheet of paper so I can do this a little bit better. Okay, so let's do this problem. Oh, this is problem number 2 on the assessment, so let's not. Let's do this problem. N equals 1 to 5 of 2n plus 1. Okay, this is a sum problem. So it says, hey, you're going to start with 1. You're going to plug 1 in here. So what do I get if I plug 1 into this function? 2 times 1 plus 1, what do I get? 3. And then I'm going to plug 2 into this function. What do I get when I plug 2 in? 5. Then I'm going to plug 3 in. What do I get when I plug 3 in? I get 7. Then I'm going to plug 4 in. What do I get when I plug in 4? 9. Then I'm going to plug 5 in. What do I get when I plug in 5? 11. And then I'm going to plug, no, I'm not going to plug 6 in. Why am I not going to plug 6 in? This problem. Because there's a top number. This number tells you where to stop. This number tells you where to start. Does this always have to be a 1? No. I could put 3 here. It means that my first number that I plug in would be 3, and then 4, and then 5. Okay? So it just tells you where you start. So what is my answer here? So if this is the problem that I gave you, it says, so basically this is saying add up all the numbers when you plug in 1 to 5. So 35, do you guys agree? So now this problem is on your assessment this week. This is a much harder problem. Why? There's 20 numbers I have to add up. That is going to take me some time. And trust me, there's harder ones on the test. Oh no. So there's a much easier way to do it. I'm going to give you an easier way to do it. I'm going to give you a way that you can snap your fingers and it's done. All right. So follow along, guys. This is an easier way of doing it. Well, you can't always use this method to get your answer. So let me show you an awesome way to get the sum. And remember, our answer was 35, so we're going to use the same problem. Okay. So I'm going to go to our little thing called Desmos. Okay. You guys see Desmos calculator? All right. In Desmos, if you go to functions, go all the way down to calculus. Now, can you guys see that? Yep, you guys can. So I'm going all the way down to calculus. And I'm going to hit this button right here that says summation. Guess what? N equals 1. What do we go to? 5. And what was our equation? 2n plus 1. So 2n plus 1. Uh-oh. Did you guys 2n plus 1? 1 to 5? Did you guys get the wrong answer? Was it 2n plus 5? Uh-oh, I gotta go back because I can't see you guys writing. All right, let me go see if that was the correct, because that's the way I would do my problem. All right, so I gotta put my share files. What was this, week 11? All right, main lesson. So, oh no, what the heck is going on here? Main lesson. Oh, shoot. Shoot. Something's wrong here. Let's go back to this one. Okay, let's see. All right, there we go. Oh, that's Algebra 1. What the heck is going on here? I have, I got the wrong, where is the right file here? Shoot, week 11, main lesson. All right, let me see if that's the right one. Okay, whew. All right, so we were down. Where were we? We were here. Okay, and there it is. So did we add this up wrong? So if I put 1 in here, that's 3, 5, that's 8, 15, 20, 15, 24. Oh my goodness, how come Desmos gave me a different answer? No. Huh. Interesting. Okay, well, I don't know why Desmos gave me the wrong answer. No, because we got it right. I mean, this is absolutely correct. I mean, you guys did it right. We put 1 in here. We got 3. Then we put all the way up to 5, so that's 11. That is correct. This is the correct answer. I'm not sure why Desmos is giving me an incorrect answer there. That is interesting. No, we did it right. Did I use the wrong sigma? I don't think there is any different sigmas in there. Let me go back and check. Because that is disappointing. Because I know my calculator does it. I know my calculator does it also. I just don't know why that gave me a wrong answer. Interesting. Okay, well, is there a setting to change? I don't think so. I'm gonna. Okay, when you guys were in Desmos, did you guys do the same thing? Did you plug it in? Did you get the same answer as 31 or did you get 35? Yeah, calculators should give you 35. I know calculators also have that. I got 31 in decimals also. Interesting. Very, very interesting. Okay, now, Samantha, you have a graphics calculator, I'm taking it? Okay, so Samantha, I want you to do this problem up here on the board. I want you to do the summation of r is equal to 1 to 20 of 3r plus 1. And I want to see what you get. And I'm going to do it on Desmos and see what I get. 3r plus 1, so 1 to 20. So I just want to see if Desmos is wrong on all of them. So that's 1 to 20. You always have to use n because they don't let you use r there. 3r plus 1. So plus 1. I get 631. What did you get? 650. Are they? I'm thinking. All right. I think I know what. I know what's wrong. I think they're missing the last term. If you think about it. So you have 650. We ended up with 35. I have a feeling they put 0 in here. But 0 won't do it. So let's try. If I put 20 in there, that would add, that's 60, 61. So that would add 61 to my answer. Nope, that does not do it at all. Interesting. Well, so much for that concept this week. So now you're going to have to do it by hand. Now, Angela, you're absolutely correct. If it's an addition one, that you can do it that way. You do the first term, last term, divide by 2. That does work. So there is another formula that we can use. It is called, you got to figure it out? Okay, Hari, what's wrong now? Oh, you have to add the parentheses? Okay, so let's try putting in parentheses. All right, so I'm going to put parentheses in here. Oh, look at that. As soon as I put one parenthesis in there, it gives me 650. All right, so you have to put parentheses in there. I don't know. Oh, because it's just adding, it's plugging the numbers into 3R. Oh, I get it. So what the calculator is seeing, what Desmos is seeing, it's seeing this. It's seeing the summation of R equals 1 to 20 of 3R, and then it's adding 1 at the very end. That's what it's doing. Interesting. So if you're going to use Desmos, which I highly recommend, put parentheses in here. Okay. Oof. We almost got that. Because that's going to make these problems really easy on the assessment tonight. What did we say the answer was here? 650 for this one? Okay. So now I have to go back and change my answer key. I think somebody took the test the other day and got them all wrong. However, it probably was my answer key. Oh no. Oh no. Did anybody take the assessment in here yet? I hope it's okay. Angela, did you get all of those marked wrong on problem number 2? No, you don't have to show your work. No. I bet you're the one for 11A. Yep. I bet you I marked all yours wrong, and it was probably my answers that were wrong. Send me an email today, and I will recorrect that. Okay? Sorry about that. All right. Well, yeah. Yeah, yeah, sorry. It's probably all mine are probably wrong. Sorry about that because I use Desmos. All right. Oh, that's not what I wanted to give you guys. I wanted to give you guys today's. This is good. Thank goodness we don't have class on Monday. I got to get to Algebra 2 here. Week number 11. And let's go to, okay. So here is, oh, maybe that is the right one. The lesson tutorial for this week covered totally different concepts? Really? Interesting. Oh, that's interesting. That shouldn't happen. Well, then you're ahead for next week. Okay, so let's take a look at this week's practice problems. All right. First problem. I better share my screen here for you guys. I think you guys are going to find the practice fairly easy this week. Let's see here. So week number 2. Okay, so here in this problem, this is an explicit formula, right? And this problem, it just says find the third term of the sequence. Okay, so what is the third term of this sequence? Letter D, 33. Now, since this is an explicit formula, all I have to do is plug 3 in here. 8 times 3 is 24, plus 9 is 33. Easy problem. Number 2, it says find the fourth term of the sequence. Okay, what is the fourth term? And then this one, again, you just have to plug 4 in. 1 over 4 plus 3 is 1 over 7, which is letter D. So fairly easy practice so far, right? How about number 3? Number 3, it says find the second term of the sequence. Now, be very careful. And let me talk about this for a second. If you have -1 to the first power, that's -1. -1 to the second power is +1. -1 to the third power is -1. -1 to the fourth power is +1. -1 to the fifth power is -1. -1 to the sixth power is +1. Do you see a pattern here? Okay. So anytime you have a negative to a positive power, it's going to be positive, or an even power. If you have it to a odd power, it is going to be negative. So in this problem, it says find the second term. Well, -1 to the second power is +1 over, and then 2 to the sixth power. Oh, 2 to the sixth power, get my trusty calculator out, and that is 64. Uh-oh, D again. Okay, all right, number 4. It says find the third term of the recursively defined formula. Okay, so I'm going to let you guys do this one on your own. Okay, and the reason is I want to take attendance right away. Okay, so I'm taking attendance. You guys do that problem, and I will be back right in a hurry. All right, so this problem is definitely recursive. Why is it recursive? Can somebody tell me why it's recursive? You should be able to look at it and say, oh, this is a recursive formula because it gives you the first term, right? Gives us the first term. So right away, I know the first term is 8. Then the second, and it asked me to find the third term. So I need to find the second, and then I need to find the third. Okay, so in this problem, it's 6 and then parentheses 8 minus 6, because we use the previous term. So 8 minus 6 is 2. 6 times 2 is 12. That's my next term. Then if I want to find the third term, which is what they're looking for, I go 6, and then 12 minus 6. 12 minus 6 is 6. 6 times 6 is 36. So another D. for an answer. So recursive formulas are a little bit tougher, but they're not that bad. It is just a little bit more work, right? No, I'm not. I did not plan them all to be D's for the answers. All right. Find the fourth term of the recursively defined sequence. Ouch. Ouch. That one is going to hurt. All right. So in this problem, they want the fourth term. The first term is 5. Okay, so I've got 5. How do I get the next one? Well, I put 5 in here. So that's going to be 1/10. Then to get to the next term, I have to put 1/10 in here. Oh my goodness. So that's going to give me what, 50 tenths? So this is, oh, what is that? 1/51 tenths? That's my third term. Now my fourth term, oh, and I should reduce this down, right? I shouldn't leave it as 1/51 tenths. That really should be 10/51. That's a, or what do we call those? Complex fractions. So I don't want to leave it as a complex fraction. So that's 10/51. Okay, so that's my third term. I need to get the next term. So that's going to be 1/5 plus my previous term, which is 10/51. Ugh. So that means I need a common denominator of 51. So that means I have to multiply this by 51 on top. So is that 255? Okay, so that's going to be 1/355 over 51, which is 51/355. Ooh, letter T. So you have to know how to do fractions. I mean, this one, I would never ask you to find the fourth term of a recursively defined function like this. So let me go through it slow. All right, so let's erase that. This is a recursively defined formula, okay? Which really means you have to take the previous term to get to the next term. So in this problem, I know the first term is 5, right? So let's find the second term. Well, how do I find that? I have to go 1/5 plus the previous term, which is 5, right? So that gives me 1/10. You guys get that? So the second term is 1/10. Now this is where it's all going to go to heck if you don't know how to get a common denominator. So the third term, so to find the third term, it's going to be 1/5 plus the previous term. Well, the previous term is 1/10. I have to get how do you add 5 plus 1/10 together? Because that's what's on the bottom, right? Well, in order to add, I have to have a common denominator. So the common denominator is 10. Well, 5 written with a 10 as its denominator is the same thing as 50/10. 5 is the same thing as 50/10. So that's why I came up with 50/10 here. So this becomes 51 tenths. That's not my third term because that's 1/51/10. This is a complex fraction. I'm going to flip it over and it becomes 10/51. That's my third term. Okay, I went really slow on that. Is that okay? So that's how I came up with 10/51. Now the next one, and this is where it's the fourth term, I've got to take, so the fourth term, I'm going to take 1/5 plus the original one. So that's 10/51. Well, guess what? Now my denominator is 51. So I have to rewrite 5 with a 51 on the bottom. So that means I have to multiply the top by 51. So I think that gave me 225, wasn't it? Plus 10 over 51. That gave me 230, 235. Or was that, is that wrong? 51 times 5. That's 5, 225. So that's right. So that's 235. Nope, that doesn't look right. I think that's right. Okay, so 235. I think I made a mistake. I know, that's what I'm looking at. So where did I make my mistake here? Oh, 5 times 51 is 255. That's where I made my mistake. I can't multiply. This is 255. Okay, so 51 times 5 is 255. No, it's 51 times 5. Ah, 255. Yep, that's right. So then if I add, that gives me 265. So that's 265 over 51. So this becomes 1 over 265 over 51. Hence, complex fraction. I got to rewrite it as 51 over 265. And lo and behold, another D. Who would have thunk it? All right, did I slow down enough for that one? Nope. All right, so let's go to problem number 6. Number 6, it says, describe the pattern in the sequence, find the next 3 terms. Okay, so this is a fairly easy problem. Describe the pattern, and then find the next 3 terms. You guys are just saying D before you even check the problem out. Stop it. It's not D. It's not D. Oh, I'm sorry. It is D. I was looking at letter C. You are right. D is correct. Why? Because it's always going up by 2. So the next couple terms will be 21, 23, 25. Letter D is correct. Is everything going to be D today? They can't be. It just cannot be. All right, number 3. It says find the indicated term of the sequence. A sub 14. That means you're looking for the 14th term, right? Okay. So now, the 14th term. If I put this to the 14th, negative 1 to the 14th is positive 1. And then put 14 in here. 2 times 14 is 28. Minus 3. So that's 1 times 25 or 25. Oh, it is D. Holy gee. Oh, I'm pulling out my hair, guys. It is D again. Oh, man. This is crazy. How can the multiple choice, every one of them be D? All right. Let's try number 8. Come on, number 8. Let's not be D. All right. So now this one, it says the plus 3 minus 2 times 1 plus 3 minus 2 times 2 plus 3 minus 2 times 3 plus 3 minus 2 times 4. I have to add all those up. So this is going to be 3 plus, what is that? Oh no, wait. Yeah, that's 3 plus 1 plus -1 plus, is that -6, 3, so that's -3 plus -5. Is that right? So I have all these, so that's going to cross out. So -5. It's not D. It's not D. It's letter A. So that is how you do a summation problem. It started with 0 this time. It went all the way to 4. So we have to just keep plugging them all in and then just add them all up. Okay. Yeah. Well, this one was only up to 4. All right. So if this said 40 on here, I would have been going to my calculator right off the bat. There was no way I was going to add up 40 of them. Okay. But it was only up to 4. So it's like, I can do this one without having to jump into Desmos. Did anybody jump into Desmos? Did you get -5 for an answer? Or did you use a graphics calculator? Did anybody do that? Okay. And you came up with -5? Okay. So it does work. So now it works. You can do it by hand. But if it was much more than 4 up there, if it was to the 10, I probably would have went to a calculator. I wouldn't have did it by hand. But this one, there's only like 5 numbers that I had to do. So it wasn't that bad. So that's why I did it by hand. Okay. All right. Problem number, I don't even know what number we're on anymore. Okay. Is the formula a sub n equals -4n, n minus 1, is it explicit or recursive? Find the first 5 terms. Okay. Is it explicit or recursive? Explicit. Absolutely. Why is it explicit? Because it doesn't give us the first term. Right. So we know it's explicit, and then it asks us for the first 5 terms, right? Well, if I want to find the first 5 terms, I just plug in 1. So that's going to be -4. 1 minus 1, that's 0. So I know the first term is 0. Okay? So I could probably stop right now, couldn't I? Because there's only one problem out in there that's explicit with a 0 for the first term. So, oh no, another D. Darn it. We're back to D. Oh. Yeah, I guess you could pass this practice if you had D for everything, right? Yeah, you could. All right. This problem here, it says for the series n equals 1 to 5, n plus 4, find the first and last term. Oh, it's not asking us to find the sum. It's asking us to find the first and the last term. So we know we're going to have to plug in 1 to get the first term, right? So if I plug in 1 here, n plus, so the first term is going to be 5 plus dot, 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 and then it wants the last term. Well, if I plug 5 in here, the last term is going to be 9, isn't it? So the first term would be 5, the last term would be 9. So my answer is letter C. Woo! Yes, 1 plus 4 is 5. It is 5 today. It is 5 tomorrow. It was marked wrong. Letter C on the practice was marked wrong. Okay, so what problem is this? What number are we on? I don't even know what number we're on. So let me jump in here. Okay, so what did you guys say? Oh, this is number 10? Awesome. Okay, so number 10, we said the answer. Oh, I have D for the answer. I probably got all flustered that everything was being D, so I just made a D. The answer is C. I agree with you guys. So I'm changing that right now. So, whoops. So that should update everybody that took theirs. Okay. So that should be C now. So a fairly easy week this week. Next week, we're going to do arithmetic sequences and series, which just deals, it's super easy. And then the following week, we're going to do geometric sequences and series. So a fairly easy couple weeks coming up. All right. That is it, guys. That was number 10. Have a great week. Yes, it will, because then we're going to do probability for the last 2 weeks, which is super, super easy. So yeah, the rest of the year is going to be an easy one. Have a great Easter. Bye. And vacation for those of you that are going.